Hey robot makers, do you want to make your own cute Pomodoro timer desk-based robot that can help you be more productive too? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's go over to our keynote and have a look what this is all about today. So yes, this is about a Pomodoro-based robot. I'm going to have a look at what this is all about, how to build it, working with time in MicroPython, doing a bit of string formatting in MicroPython as well, because we have to play around with time quite a bit in strings. So we're going to be doing that today. And we'll also be looking at how to do things like add leading zeros to our MicroPython code. This is something that a bit fiddly if you've not done it before, but it's really straightforward. And you'll know what you're doing by the end of this session. And we're going to build a countdown timer, like a really simple countdown timer, build it into our HeyBot robot, and we'll have a look at how to 3D print, get the STL files, download this and build our own as well. And if you're watching this live, you can also join me on the Q&A at the end of the session, and we can have a bit of a chat and hang out there as well. So let's have a look and see what this is all about today. So what is this Pomodoro technique all about? So Pomodoro is a type of small tomato, is that right, Alex? It's Italian for tomato. And the Pomodoro technique is a time management method developed by this Francesco Cirillo, I think that is, in 1980s. It uses a kitchen timer. He was a student and he had this kitchen timer that's shaped just like a tomato, and he would set that to like 25 minutes and work on something really, really focused, intensive working on something. And then he would take a short break after doing that, and then he would set the timer again and carry on. And he found this to be a real productivity boost. And there's like a whole industry based around this technique that's developed now. So each of these intervals, these 25 minutes, because you can change how long it is depending on what works best for you, they're known as a Pomodoro. And you can use different times, like I said, depending on what suits you best. The idea is you do a number of these, and they consider to be like a set. I think it's about 4. So we'll have a look at that on the next slide, a bit more about the steps that are involved in this, and then we'll get into how to build the cute robot. So the goal of this technique is to reduce the amount of effort of internal and external interruptions on your focus and flow. So the idea is if you're like writing something, you're researching something, you need to get your head down and just produce something, then this is a really good technique for just getting the work done. So the original technique has these 6 steps. So the first one is decide on which task needs to be done, and there's all kinds of techniques for figuring out which is the most important and urgent task to work on first. Then you need to set your Pomodoro timer typically for 25 minutes. Then you're going to work on the task. At the end of that time, your timer will ring and you'll be able to take a short break, 15 minutes, 15 minutes, something like that. 5 to 10 there. I would take as long as you need to sort of just reset your brain and then move on to another task, or continue that other task if that's still the most important task to be done. If you've fewer than 3 Pomodoros, go back to step 2, repeat until you've got 3 Pomodoros. The idea of this is you get this set of them, and each one of those sets means that you've got like a really constructive block of time being used. And after 3 Pomodoros are done, take the 4th one and then take a long break, typically 20 to 30 minutes. And after the long break, get back to step 2. So again, this is designed for people who are doing work where they need to focus, they need their attention to be on this task, and they get rid of any distractions. I know quite a few people who don't even bring their phone into the room that they're going to be working in, just to make sure that they don't get distracted by that. Okay, so MicroPython and time. We're going to be doing quite a bit of time stuff today with it being a timer, so we need to learn about how to do this. So the first thing we need to do is import the time library. So MicroPython's got this great little time library, and it's got a couple of different functions that we can use there. There's one that's called GM time, there's one that's called local time, and then there's something called the RTC. So the RTC is the real-time clock. If I just grab hold of one of these little Picos here. The original Pico I don't think had a real-time clock on board, or if it did, it would only have been able to be set manually, because it has no way of communicating with the outside world other than through that USB port or perhaps a UART connection. Whereas the new Raspberry Pi Pico W, it has this nice Wi-Fi chip on it, which means that we can communicate with the outside world and things like network time providers, NTP servers. So we can grab the actual time, set our real-time clock, and then all the things that we do that are time-based will then be accurate on what the current time is. So the time is represented in MicroPython, a bit like other Unix systems, as a number, a really long number. And that number started counting in seconds from the Unix epoch Or if it's like I said, one of these Picos that doesn't have the Wi-Fi chip on, it's from some other epoch, such as when the build was done, like the firmware build, for example, and it's just like a known point in time that you can count forward for. So if you don't need to have a really accurate current time, you can probably use a Pico that doesn't have a Wi-Fi chip in it. But if you want to get the actual time now, you're probably going to need to have that real-time chip and access to Wi-Fi as well. So the Unix epoch, that's 1970, 1st of January, at midnight, and the number of seconds since then is what's known as the Unix epoch. Well, the number of seconds is the count since the epoch. The epoch is that event in time. So if we want to grab the time, there's a couple of different ways that we can do it. We can just do time.time. We're going to have a play with this in a second. We're going to dive right into that. And we can also use something called GM time. So GM time is the Universal Coordinated or Greenwich Mean Time. And it's like an adjusted time zone, adjusted time depending on where you are. And you can offset that just by an hour or an hour and a half or whatever the actual adjustment is for time zones. Or you can just use local time, which doesn't worry about time zones at all. So for our purposes, I'm in Greenwich Mean Time. I'm in the UK, so we're in UTC 0, GMT 0 most of the time. Actually, British Summer Time at the moment, but I'll skip over that. So when we actually grab I've got this clock thing behind me, and it's going to keep doing this throughout this video. It's actually not wound up at all. I think it's just haunted. So it's deciding that it's 6 o'clock in its mind. I just moved it before. I think it just got some momentum. The actual pendulum isn't connected or anything, so really spooky. Anyway, that's another project. So when we grab time from local time or GM time, we're actually going to get a tuple back. So a tuple is it's like an array of numbers. So we can see there we have this array of numbers on the screen here, starting with the first digit that's going to come back is the year. So we'll see that will have 2002 in there for this year. Then month, so we just did October now, so that should be 10. Then we're going to have the day, so we're in the 2nd of October now. And then hour, minutes and seconds. And then you also have a couple of others at the end, such as what the weekday number is. So is it like 0 for a Sunday? I'm not sure. We'll have a test of that in a second. And also the year days, so how many days through the year have we got up to? So they can be quite useful for doing various different things. And that means if we want to then build like a string to print on a display or something like that, we'll have to pick off each one of these individual things and then build up a string. So this is what our countdown timer has some functions for helping us do that. And we can also do it the other way around as well. There's something that's called make time, MK time, and we can basically feed in using that same tuple format. So you can see that I've got Halloween, so 2002, 10, 31st, and then just left the rest of zeros. We don't worry about that. And then we've said H equals make time, and then it brings back a really long number, which is Halloween. It's that date, but represented as one of those Unix long numbers. So we're going to have a play with this now, and let's break out to Thonny. So let's jump over here. What I'm going to do is just do a nice new window here. And what we can now do is we can just have a play with time. So the first thing I'm going to do, I'm going to just load up. So I've got a Raspberry Pi Pico, the one that's actually connected to the robot there. We're just going to play in there. So we can actually play just on this REPL and learn a few things about time. So if I do import time, that's the first thing we need to do. You can actually do dir and then in brackets time to see what kind of functions does it have. So you can see there we've got GM time, we've got local time, make time, we've got sleep. We've used sleep in quite a few of our projects. And we've got these other ones like diff, ticks, diff, ticks, ms, ticks, us, time, and time ns. So let's not worry about those just yet. Let's do t equals time and then brackets. Oops, time.time I should say. And if we now print out what t is, we can see it's that really long Unix number. We grab that again. So let's grab that and then just print it out again. You can see it's changed slightly, and that's because we've got, we've moved forward slightly in time since then. So, and that's in seconds. You can see that it was 7 seconds since I reset between those two. So that's how we can grab the current time as one of those really long numbers. And you might think, well, that's a really ugly thing. I want to see it as like a date that I can understand, like the day, the hour, the month, the hour, the minute, the seconds, and so on. But if we're working with time, it's really handy to actually work in the seconds, because we can very quickly scale up and scale down things without having to worry about how, if you want to say compare whatever the time is now, 7:15 with 3 a.m. tomorrow morning, how do we calculate that? If we were going to do that without using like a long number like this, it would get quite complicated, because we'd have to figure out, you know, what the current day is and compare each of those. And you've got days which are, they're numeric. You can have 365, 366 in a year, depending if it's a leap year or not, and you'd have to figure that out. Month-wise, you would have to make sure it's less than 12, greater than 0. And then days, is it greater than 0, less than 31? But it depends what the month is. So October, it's got 31, September had 30, and so on. So you would have to figure out an algorithm that would have all that kind of logic built in. Whereas if we just work with a number that's basically the number of seconds since that Unix epoch, it's so much easier to work in that and add and take away, and then convert that back using something like make time or time. So the next thing we're going to do, we're going to grab the local time. So let's do t2 equal, and then local time dot time. I think it's the way around, sorry. Let's just do, so the name of the library and then the name of the function within that library. So if I now do t2, let's do print t2. We can now see we get that tuple back. So we can see that local time, instead of providing back that really long number, we're actually getting a nice date, a nice format that we can work with. So we can see there the first part of the tuple is the year, the month, the day, then the hour, the minutes, the seconds, the day of the week, and then also the day of the week counts up from 0. So 6 is the last day of the week, 0 will be Monday. And then we're on the 275th day of the year. So that's what we can do with local time. So let's try something else. Let's work backwards. So if we say Halloween equals, and then let's start a tuple. So we're going to say 2022, then 10 for the October, the 31st, and then let's just do 5 zeros like so for the rest of them, because we don't care about that. We just need to make sure we have 8 digits in our tuple. So now if we say h equals make time, so time.mk time, and then we put in Halloween, and now we print out what's in h, we get that long number. So we can now do things with that. We can see how many days is it until Halloween. We can take the current time, minus that by the Halloween time, and then we can work out, by converting it back using make time, how many actual hours, days, minutes, you know, that are remaining. So let's try something else. Let's try adding something to time. So we're going to play with some duration now. So duration equals, let's say 25 minutes. And what we're going to say is the current time equals time.time. And the target time, so let's make a timer for those 25 minutes. So target time equals the current time, which is one of those long numbers, plus, and then let's just do in brackets duration, spelled correct, duration times by 60, so it's working in seconds, and then let's see what that target time looks like. So we can see there we've got like a slightly longer number. We can look at what the current time was when we took that snapshot, like so. And then if we want to do something like work out what that would be from now, let's have a look. So if we do t equals local time, so time.local time, we can pass it in that long number. So if we pass in the target time, and then we print out t, we can see now that that target time is 25 minutes into the future. So there's the hour, there's the minute. So 43 was 25 minutes from that that current time as we captured it. Now we can do some other things, because sometimes seeing the format like this isn't particularly helpful. So what we could do is we could say year equals, and then t, the first element of that. So if I just echo year, we can now see that we get 202. Now if we do month, let's see, T1, let's print out month, not mouth, so we're getting the 10th, and then we want day, and that's going to be T2, there we go. And then if we do hour, T and 3, let's print out hour, 19, minute equals T4. And finally, there we go, 43, and that's based on the target time, remember, not the time now. And then seconds equals T and then 5. That's what we need. And if we want to do something with that, we could actually build up a string. So we could say print out, and then let's do our, let's do one of those little separators, minute, and then another separator, and then a second. Let's just print out that. Oops, so it's not happy with that. Seconds with an S on the end. There we go. So 7:43 and 0 seconds. So see there, our 0 has only got 1 0. Normally when we format time, we like to have a leading 0. So we're going to have a look at how to do that in a second or two. Right, so let's get back to our keynote. So that's some playing about with time in MicroPython. I advise you to go and have a play with that. It's really, really good. So strings is the next thing. So we worked with time using numbers. We want to sort of think about how do we do stuff with strings. So let's have a quick look at that. So you might have seen very simply, you can store, you print something out such as my name Kevin. You can store a string in a variable. So my name equals Kevin in brackets in speech marks, either single or double speech marks. You can then print that variable, print my name, and it'll print out what's inside the contents of that. But there is also something called fast strings in Python. So fast strings, F strings, we can do some really funky things with those. So you can insert variables within the string in a way that makes sense as you're writing the code, rather than something that looks quite ugly. So if you've ever worked with strings before and haven't used F strings, you'll probably know what I'm talking about there. So we're going to have a play with this and have a play with some F strings. So you can see that F strings, so you just put an F in front of the first speech marks, and you can either do that if you're assigning that to a variable or if you're printing it out. That's what you do. You just put the F in, lowercase f in front of it, and then you can put the squiggly brackets and put your variable name within the string, and it makes total sense there. So let's have a play with that in a second. Now before when we was playing with that time function, we saw that we only got 1 0 back, and really when we print out time we want to have 0 0. That's the format, isn't it? So you can see down the example I've got at the top of the screen, if I say a equals 0 9, I print out a, I just get 9. It gets rid of that leading 0. It doesn't actually store it. So if we want to put that back, we have to use a little bit of f-string magic, which is this colon 02. And the 02 means fill the number of zeros to these number of places, but keep the actual value of the number in there. So if you do a colon 02, you're saying we want some leading zeros, and we want this to be, want to fill to the 2 decimal places there, or not decimal places, to the 2 character places. It makes more sense as we play with that and have a go with this. So let's jump into the demo. Let's go to Thonny, and let's carry on. So first thing I'm going to do, you've seen this before, you could just print out just using the print, and it'll print to your console. We can assign variables. So if we do my name is Kevin, good grief, and then if we print out my name, we get the variable printed out. If we want to do some funky things, such as if you want to print out some speech marks, there's a couple of different ways that you could do that. So if you wanted to print out, this is a speech mark, something like that. And then let's do something like, I think you have to do / and then the speech mark. Let's try that. There we go. So you've got that little speech marks, or you don't have to worry about that. If you've got it inside single quotes, you can put a double quote in there, no trouble. If you put just the single quote in there, it will get confused. So that's why we have to put that little / to say, just ignore the next character, just print it out. Similarly, you can use double speech marks within a single quote, and vice versa. If you've got, let's go to the very beginning of that line there. If we have double speech marks, you can put single speech marks within that, no trouble. It'll print them out. So again, if you're working with strings and you want to put a speech mark, single or double quote marks in there, think about, do you need to use that forward slash, or do you just need to make sure it's sort of wrapped in the correct ones for the one it's not being used, if that makes sense. Right, so the other thing we're going to do, it was use these F strings. So let's go back to here. Let's print a new string. So we're going to use an F string. And what we're going to do is we're going to say my name is, and then we're going to use these squiggly brackets. I don't know what the correct term for that is. Curly braces. Are they curly? They're those ones. And then we're going to put the variable that we created a minute ago, which was my name. And what it will do is it will sort of backwards slash. No, the curly braces, what are they called? So we put them. It's going off again. It's not been half an hour since it went off last time. It's going fast time. So there we go. My name is, and then we've got the variable name within the string within those curly braces. So it makes it a lot easier to write, a lot easier to understand. You don't have to do funky things. So if you weren't going to use these, you would have to do something like my name is, and then one of these horrible like %1 things, and then comma, and then my name. And it's not even done that there, has it? %1. I can't remember how you do this now. It's just such an ugly way of working. So I don't like, I like F strings. I don't like working with those. So let's do the other thing. So if we just print out minute, it's got 43, the seconds was 0. Right, so we want to work with a leading 0. So a second, we can work with that. So if we say print, and then we do, I make it an F string, so put the little F in front of it. And then within the quotes, we can say minute, and we can do 02. And this needs to be also, because it's a variable name, inside those curly braces. There we go. Oops, so what have I done wrong there? Minute without an S. There we go. 43, and let's try seconds, because seconds is the one that had just the single 0. And it was seconds with an S, because I was inconsistent there. And there we go, we've got our double 0. So we can use this if we're formatting our time and we want to have like 01:01:09 or whatever. So we can then do things like print F. Let's do hour. Like that. Then we can do our little colon, then we can do minute with 02, and then we can do colon, and then it was seconds with an S at the end, wasn't it? Seconds -2, and then close out our thing, and then we've got a nice looking time there, so 1943:00. So F string, our normal quotation marks, curly braces, the name of the variable, colon 02 means we want to have 2 characters, and we want to fill in front of them as many zeros as we've specified there, which is 2. And then because we've ended that curly brace, it's then just going to print out whatever's in the string. So I've just put that colon as a little separator. So we could change that to be, I don't know, a dot if we wanted it to be a dot. Oops. Oh, we'd need to do that again. And then if you wanted it to be like a full stop, for example, you could just change that. Or if you wanted it to be just a space, you could put a space, whatever you want. If you wanted a dash, you could do a dash. This is just whatever you want in that string there. You get the picture. Okay, so that's everything I wanted to cover off on there. So let's get back to our keynote. Okay, so countdown timer itself. We're going to play with, we're going to create a countdown timer using the countdown timer class that I've created for this project. So we need 3 different things for our countdown timer. We need the current time, we need a duration such as 25 minutes, and a future target time, which is a calculation of that target time. Oh, sorry, the target time is a calculation of the current time plus the duration. And we need to just make sure we calculate it in the correct units. So if we're working in minutes, we need to use minutes. If we're working in seconds, we need to work in seconds. Much easier to work in seconds because that's the smallest number of units, and that's what the native Unix timecodes are all stored in. So as we see on the screen there, we can use these built-in functions, make it easier to do our math, compare times, add times, remove time, all that kind of stuff, and then convert back, just as we've seen earlier. So let's have a play with the countdown timer. So I'm going to go back to Thonny, And we're going to do the last thing on here. So I've created this this library that's called Countdown Timer, and in here there's a Countdown Timer class, and it allows us to do things like set the duration either in minutes or seconds. We can reset the countdown timer, we can convert, we can basically have a nice pretty version of our string, so we'll get the hours, minutes and seconds using that leading zero thing, using F strings. And we've got that for the current time, the start time, the target time, the remaining time. We can even have that so it actually counts down, which is quite nice. And we've got an isAlarm. So isAlarm says if the remaining seconds is 0, then we want the alarm to be true, otherwise just return false. And I've got a thing there just called tick. It just returns the remaining time. It's just a way if we wanted to do something with that, to display it on the screen, for example. And then there's another one I've called status. And status is for printing out a little table. So it'll print out what the start time is. So it will say start time is, and then the variable self start time string, which returns the string. And I've got this thing at the end that says end equals quotation marks. And what that means is don't print these on new lines, print them all on the same line. So we'll have a play with status. So it'll print the status line as long as the alarm hasn't gone off and it hasn't reached its target time. So let's create a new file. Let's go from countdown timer. And we'll have to make sure that the countdown timer is actually uploaded to our Pico. So you do like a right click and upload to, just to make sure it's on there. So from countdown timer, import countdown timer, capitalize like so. We're then going to say t equals countdown timer. We're going to say t.duration in seconds, because we don't want it to take 25 minutes. That'd be quite a boring tutorial, wouldn't it? So let's do 3 seconds, and then we're going to say while not t.isAlarm, do this loop. So t.status. Okay, so let's run that. And if you can see there, it's counted down. Let's run that. Let's do it for 10 seconds, because that was a bit too quick. Let's run that. So it says start time is 7:32 and 27 seconds. The current time is going up there, and the target time is 37. And you can see there the remaining time is ticking down on there. So let's just run that one last time. So you can see there, if I move, I can move me slightly, oops, out of the way. Well, I've just ruined that, haven't I? You can see there it's counting down to 1 second, and then it stops because it's reached the point where the alarm has been triggered. So that's how we can use our countdown timer. That was quite a lot of code to actually make that happen behind the scenes, but it's all nicely wrapped up in this countdown timer class that I've created that you can have a play with as well. And what we're going to do next is we're going to have a look at the actual the code for the robot that will display a nice little animated face, and it will have a countdown timer as well. So let's get back over to our keynote and continue our journey. So very, very quickly on the 3D design, I'm not going to sort of labor this one too much. So I created this little robot, and it basically holds a Raspberry Pi Pico W with the header pins on it. And I also have the Pico Display Pack 2 from Pimoroni, which is perfectly designed to sort of connect to the back. So they call these packs when it plugs into the back of the header pins there. So you can see there's like a little diagram that, oops, if I can just point that out there, there's a little USB diagram on the board, and there's the physical USB, so you just have to make sure they're both the same way round. So what I've done in many of the other projects I've worked on is I've created a little mounting holes in 3D that's basically the same width as these little holes, so an M2 screw is perfect for screwing through there into the plastic. So quite simple dimensions. I think the distance between the two center points is something like, no, it's not the center points, it's the edge of the mounting points is 51, and then it's like 21 tall, and the center point between the two mounting points is something like 11.4 millimeters. So if you want to grab the CAD files, you can do. The STL files, I should say, they're on kevsrobot.com/HeyBot. I'll put up a link here in a minute, and you can grab them yourself and have a play with it. So very simple. We basically just put the Pico in place, screw the 4 screws into the head. There is also a hole there, a boot button access, so you can get your pencil and you can basically shove that in and click the reset button. The number of times where I printed something out, screwed everything down or glued it all in place, and then realized I need to hit that little reset button, that boot button, to either upload some new firmware or whatever. Curse myself. So I've made sure on this one I've got like a little hole to poke through there, and there's also the USB port on the side as well, so that we can plug our cable in, and everything just held reasonably nicely in place there on the head. Okay, so the other parts are the body. So the body basically just holds the head. Now the original idea for this, if I see if I've actually got one to hand, was that I would have a tiny little button. I think I've probably thrown it in a temper tantrum somewhere. I can't see it now. It's basically a little tack switch. I've not got them to hand. You've seen tack switches before, I'm sure. They're the little square buttons, and basically what I wanted to do was on the body, the button will be upside down, so that if you push the head, it would click the button. And the head's very, very light, so it would spring back quite easily, and the idea being you could basically just bang the head and it would reset. It would do something like reset the timer, and we'd just have those pins onto 2 pins on the Pico, one to ground and one to a signal pin of some type, a GPIO of some kind. That was the original idea. I printed it out and I wasn't very happy with how that would work. In fact, I've got one here. This is what I'm trying to show. So on the bottom of here, there's a little tack switch there. This is a failed 3D print, but it was useful for sort of trying it out, and you can see there that the tack switch pokes through. It's not glued in place, it's just poked through there, and then I have some wires of soldered to the tack switch, just to the legs, and then you could click it on and off. It did work okay for a while, but I just wasn't happy with the way that the design works, so I basically took it off this particular version, but it will work for future versions. That will be fine. So the body and the head basically just sit on, the head sits on the body. It's not glued in place. It's got quite a secure connection, very similar in design to BurgerBot and how the pen holder mechanism goes into place there, so that works quite well. It has HeyBot written on its stomach as well. And then we've got 2 little arms as well, because why not? I was thinking about maybe having this have a little hand that could grab hold of a post-it note. I'm a big fan of post-it notes. I always have these on my desk for working on various things, even though I like working digitally as well. So really these are just currently for decoration. I could probably do another design that has 2 servos, one for each arm, and they could move around, but currently they're just positionable. There's just 2 M2 screws holding them in place. So in future we'll probably work on some kind of post-it note or something like that. So if you like my videos and you want me to make more and continue making more videos, then make sure you give this video a like. Drop me a comment. Is this something that you'll be interested in? Have you used any kind of time management techniques, any productivity hacks? Are you into that kind of stuff or not? I am, secretly. And also subscribe, hit the bell button so you get notification when I do a new video, and I try and do a midweek video every week if I can, but I certainly go live every single Sunday, so you get notified when a new video goes live if you do that. And I do go live every single Sunday at 7 o'clock GMT +1 currently, because we're in British summertime, but at the end of this month it reverts back to GMT, so it will be GMT +0, which will make it a lot easier to work with time-wise. Cool. Right, so let's have a demo of the actual robot, shall we? So this was misbehaving before, but let's hope that it's going to behave properly now. So what I'm going to do, I'm just going to get up this kind of joint view here, and I'm going to just bring down this a little bit and just move some of the screen bits about. Why is it not letting me do that? Let me just move that up again. So I'm on the newer version of Thonny, and I think there's clearly some bugs there. Look at that. What is going on there? So what am I best doing there? I'll run the code. I'll talk you through the code and then we'll run the code. That's probably the best thing to do. So yeah, it was misbehaving a little bit there. I'm not sure what was going on, but it seems to be behaving better now. Right, so There's a lot of code in this particular project, a lot of libraries, I should say. So I've utilized everybody else's really cool code. So Pimoroni have got this Few library, which is just one of the most easy, best libraries for doing stuff like connecting to Wi-Fi, for logging and so on, for fetching network time. So this project, I want it to grab the current time off the internet and update its real-time clock. So we use Few.ntp fetch for that. We're going to grab the config, which is just my local Wi-Fi password and SSID. We're going to use sock. Usock is used in the time updating function, and we've got a JPEG decoder, so we can actually get a JPEG that we've created ourselves. We can display it on that tiny little display pack, which is so cool. And then we've got things like struct. That's part of the NTP decoding thing. Don't worry about that. Basically just cut and paste the code if unless you want to look at that. We've then got time, sleep, GM time and time, which we know about all today. We've got machine.realtime clock, and then we've got the because again the haunted clock. Then we've got, it's about time today, so that's quite, I think, quite suitable, isn't it? Is it gonna No, I think it thinks it's 7 o'clock. It's nearly done. There we go. So we've got Pico Graphics, which is the Pico Graphics library that Pimoroni have created, which is fantastic, perfectly designed for these display packs. And it also means your code's really portable amongst any display that they create, including this guy, which is the inky frame as well. So if you create some graphics on that, you can use the exact same code on this, and it'll know what it's doing. It'll adapt because of what we use in here. We basically just have to change out that display Pico display to be like inky frame, for example. So we've then got random choice. We're going to basically choose a random animation and then animate that. So that's what that's for. We brought in our countdown timer, and we've also brought in buttons. We've got some clicky buttons on these displays at the edges, and I'm basically going to use one of those to reset our Pomodoro timer. So the first thing we want to do is grab the screen dimensions, and this is why I mean the code's really portable, because this has got a different screen dimension than this one has. So if we just say height and width, and then we get the display, get bounds from the display, it will help us with that. I've got an eyes.jpg, so eyes.jpg has been uploaded over here into the code, and this is basically like a really crude drawing of some eyes with, like, just think googly eyes. It's basically that on a little black background. What else do I do on here? So I then set up all the buttons. These are the GPIO pins that they're on, 12, 13, 14, 15. And then we set up some animations. So this is basically the file name of the animation JPEG. So I've got on there 7 JPEGs for the angry animation. So all I'm storing there in that little list, I always get confused at a dictionary or list. This is a list. So that's what it is for angry frames. Normal frames is just 4 normal frames, and then static frames is basically just the eyes twice. I then set up some, so when we draw to the screen, when we issue a draw command, or we want to put text on a screen, or we want to draw a rectangle, whatever the current color is will be used. So we need to make sure we set our color, and the way that we do that is by using a pen. So we can set a pen using an RGB value, so red, green and blue. So red, non-surprisingly, is 255, so it's the full byte of colors there, and then blue and green are 0. White is 255, 255, 255. All the colours are up. Red, green and blue, and black is the opposite of that, 0, 0, 0. They're the only colours I think I use, maybe a bit of blue in there as well. I then created a little animate class because I was creating this, and I started out by doing each like face that was angry or normal or looking to the left and right. I basically created a function for each of them, and then I thought, wasting your time, just create one animate class and then basically use that to animate stuff. So I usually I create an animation. So say the eyes are looking to the right, looking to the left is basically the same things but in reverse. So all I need to do is reverse that animation. So I've got a direction of animation there, so it's either forwards or backwards. We want to remember what the current frame is to display on the screen, and that's really just an index into that array of JPEG files, and then we want an array of those JPEG files that we can load in there. So frames will be replaced by that array of angry or normal faces, and then is done animating is just a true or false value. So then animate basically just says if the direction is forward, then we plus the frames. If the frame is greater than the length of frames that are in that array. So we've gone too far. We need to go backwards. And then we need to set the frame to be the length of the frame. So basically what they're saying there is if you've gone too far, just go back one. Otherwise, if the direction is backwards, then we need to minus a frame. So we want to go from the highest number back down to 0. And that's what we then do. So well, back down to 1 in this case. So if the frame equals 1, then animating is true. Done animating is true. And then here's the code that actually puts the JPEG on the screen. And it couldn't be simpler than draw JPEG. We can have a look up. It's basically JPEG decode.jpeg display. And then we want to sort of say where it goes on the screen. So I'm basically just passing in the display handler and then whatever the current frame is using that index. So here we go. So draw frame display, we're just passing in that display handler and then the file name I want to display. And the file names are stored, remember, in that array, so it gets passed down here. J.open file opens the JPEG file itself. We then grab the height and width again. Bit inefficient code this, we could have grabbed it once and then we'd have to do it every single time we open a file, so maybe that's a note for future. And then display set clip, this is basically just a clip off in case the JPEG's massive. We don't want to like waste time drawing pixels that don't exist, so we can clip the screen to be just the size we want. So we're clipping it to the dimensions of the screen, and then we do JPEG decode X and Y, the actual JPEG decoder function. We want to scale it to the full size, and then after doing that we want to remove that clip that we set earlier. So that will make it just display the picture on the screen. It's quite quick to do it actually. Next piece of code is quite technical, and I basically would just copy and paste this if you want to update your real-time clock. So it's going to try this 5 times. We're going to grab the NTP host as being pool.ntp.org. You can use like time.apple.com. There's loads of them out there. We're going to set attempt to be attempt number 1, and while attempt is less than the maximum attempts, we're going to try and do this. So this horrible piece of looking code here is really low level stuff with byte arrays and indexes and usockets and get addresses and all that. Basically just asks the internet server what's the current time, and it says here is the current time and passes it back. A bit like we've seen before with those arrays of, we're getting the GM time there, and we're then basically just loading that up into our real-time clock. Otherwise we just report an error or we increment our attempt, so we can just ignore that. And then they've got this little thing which just draws a red banner at the bottom of the screen in a colour, and it can set the background colour and the foreground colour in one go. So it sets the pen to be the background colour, draws a rectangle, and it draws it at X being 0 and Y being 210. So I would have to change this code if I was making this work on a different display. I could basically just do this as an offset from the bottom of the display perhaps. So like height minus 10, something like that might be, or minus 30, whatever it is. That's probably the better way to go, but this works for now. And then display.pen, set pen, and then the foreground colour just leaves it whatever the foreground colour was. Whatever gets drawn next will be in that correct foreground colour. Right, and then the main program. So we draw the display eyes. So that will just display the eyes looking forwards. We just log about to connect to Wi-Fi. We then try and connect to Wi-Fi. I think my local network has run out of DHCP addresses, so every time I run this, it sort of clogs up and gets really slow, and then eventually works. So I think I probably just need to reset my internet router for that. We then update the clock using that function above, so t equals update clock. We then create our countdown timer. We set the duration to 25 minutes. We set the font to be bitmap 8. I quite like the retro bitmap fonts. We then current time equals the current time string. This is something we're going to print out both to our terminal, and we're going to print this to our little robot's face as well at the top middle of the screen. And then we set some coordinates. So X is 1, Y is 1, scale is 4, angle is 0, spacing is 1. This is to do with text. And then display set pen. Then we're going to set up the animations. So the animations it's like an array of arrays. So angry frames, normal frames, static frames is what I've loaded in there. I'm going to create an animation that's called animate, and then we're going to pass in there animation.frames equals randomly choose one. So choice animations means go into this this array here and just randomly pick any of them, doesn't matter which, and it just gives it our robot a bit more of a natural feel because it's not doing the same animations exactly the same every time. We're then going to start our countdown timer. So reset makes everything, gets the current time, sets the alarm to false, and then the main loop. So we're going to read is our Y and our A button, are they being pressed? If they are, just reset the countdown timer. We want to get the current time from our countdown timer using this nice current time string. So it'll bring back that nice pretty text string with all the right formatting. We're going to set the display pen to be 0. We're going to clear the screen. 0 is black. So clearing will just clear the display, make it black. Remaining time equals countdown timer, remaining time string. So we get that nice remaining time, which will count down as the seconds go past. And then we're going to animate the face. So if not animating is done animating, then animation.animate display. So it's just going to display whatever the correct animation is for the current frame, and then increment it so it will look animated. Otherwise, animation frames, choose another one, set the animating to done to be false, and then display the animation. If you don't put those display animations, you get like a black screen at the end of an animation. It looks really odd. And then the last bit is to basically display 2 times on the screen. So one is just like a real-time clock, and then the other is the remaining countdown timer. So this one is at the top of the screen, which is using that X and Y that we set earlier. It's grabbing that current time nice text string that we created before. We're not really bothered about word wrap, scale, angle, or spacing so much. Spacing is like how many spaces between each letter. The angle, I think you can actually make the text go in different degrees on the screen if it's a vector-based font, and scale makes it larger or smaller depending on what scale factor you put in there. And now I do some clever stuff here. I want to center my text in the screen. So what I want to do, there's a function in the display that's called measure text, and it will tell you how many pixels long that text is that you've got. So you can then pass in that current time using the scale and the spacing. I'm then going to divide that number by 2. So whatever that spacing is, divide that by 2. And then I'm going to divide the whole width of the screen by 2 to get the center point. And then I can then offset using that middle point of the text to make it centered. I'm using these double backslashes because I want the division number to be not a floating point number. I want it to be a integer. So for example, if I have a number such as 33 and I say divide by 2, I get 16.5. But if I say 33 divide by 2, I get 16. So it cuts off any decimal points. So it's really useful if you're working with integers and you just want to get that right away. You don't have to convert it and wrap it in an int or anything like that. You can basically just use //. The second one will display the text, the remaining time, and it's going to do that basically at that bottom point. So the Y is going to be plus 210, so just at the very bottom of the screen. And the bit in the middle here is if the countdown alarm is true, so we say countdown is done, we want to flash the banner. And I was thinking, how could I make the banner flash? And you can do that by basically just looking at what is the current second. Is it odd or is it even? And depending if it's odd or even, we can make the banner either have a red background and white text, or black background and red text, depending if GM time 5, which is our second, is even. So modulo even means if it's divisible by 2, it'll be 0. So if you've not used modulo before, that's what that's for. And then we display the text, which is just the little banner text. So what I'm going to do, I'm going to run this code, and hopefully it will run okay. And I'll get up on the screen like so. Now this is what I was saying about sometimes it doesn't play nicely with the Wi-Fi, but it's worked. It says real-time clock has been synced, so we've got the actual time, and we can see if I zoom in on the little robot there, we've now got a countdown timer. So it says 18:53. I'm an hour out. I should be working in local time instead of GMT time. That's fine, but we can see the seconds ticking up there. We can see the animation happening. So that's like the normal eyes animation. That's the angry animation happening there. And it's just doing the static one for a second. It shows that one when it sort of looks directly at you. and then it's just doing the normal one as it looks left or right. And we can see also on there the time is counting down. So if I press that button there, I realise as well I've got this display kind of upside down, so A and B, X and Y are kind of inverted there. But if I press that Y button there, it'll reset the clock. So you can see now the clock has been reset. If I just press that again, oops, we can see there that it's counting down. So what I want to do now is just quickly change this code. So instead of it being 25 minutes, it's like 3 seconds, just so you can see what that finished animation looks like. So if I just scroll up to the top of my code, let me just bring this down so you can see a little bit what I'm doing. There we go, that's behaving now. So if I just come down just before here, and I say countdown dot duration in seconds. There's the haunted clock, and let's do 3 seconds. Let's try running that. Let's see if this is going to work. There we go. So 3, 2, 1, and then it's going to flash between. Or it's not in this case. Why is it not working? It should be flashing its animation there, and obviously it's decided not to do that for some reason. That's a bit frustrating. Let's try 4 seconds and see if that works. Don't know why that didn't work. I'll have to have a look at my code and see what's going on there. I wonder if I need to upload the countdown timer again. Yeah, that is weird. I wonder if it's to do with when it read what the current time was. It's not continually reading the current time, or is it? I'm not sure. Yeah, that's a bit frustrating. Well, so what I'll do, I'll just stop that, and I will just upload the updated countdown timer, because I was playing with this just before. Yes, slightly different sized file. So let's run this again, and we should just get the 2 seconds now once it's connected to Wi-Fi. And I think that's where it's misbehaving. So what I've found as a workaround, if I stop and start it and it doesn't work, I just need to disconnect the cable and then plug it back in. That seems to do the trick. So if I just stop that and then run that again, it's as if something's wrong with the MicroPython itself. There we go, connecting, and then it should do. Sometimes it takes a couple of seconds to grab the IP address. So you sometimes see it say connecting like second or third attempt. I'll give it the benefit of the doubt, and then I'll just give up on it. I want to see that red banner flash. I don't know why that wasn't working. Let's give that one last go. There we go. 3, 2, 1. Ah, rats. So yeah, it should be flashing red or black, basically, using that last bit of code. I just need to debug why that's not happening. I wonder if it's to do with the GM time. Let's try it time rather than GM time. Let's see if that works. Be something to do with that kind of logic, I suspect. So 3, 2, 1. Nope, that's not made any difference at all, has it? Ah, well. What is 5? We were looking at that before, weren't we? So 0 is the year, then the month, then the day, then the hour, then the minutes, then the seconds. So that should be the 6th element. 5. Well, it is what it is. Right. Cool. So let's get back to our notes. Nearly done. So next steps with HeyBot. So I was thinking about how, what would take this to the next level, what would make this really useful. I think definitely adding some sound would be good, making some kind of buzzer or some kind of alert. And I was thinking, well, maybe I could add a notification via MQTT. So I could make this fire off, because it's already connected to our Wi-Fi network, just fire off to like a node red that's listening, and then that could trigger like the lights behind me flashing. I've got all the lights connected to Philips Hue, so I can do all kinds of things, make the lights flash red or make an individual light flash or things like that. And we could also bring other alerts using MQTT to the Pomodoro client. So we could basically make it like a display thing, like, your tea's ready, or, phone call or something like that. We could basically make this little display respond to things using MQTT for notifications. And then I was thinking, what about adding an AI assistant skill to ALF for Pomodoro timer? That'd be really trivial for us to do. We could even link it to this robot as well. So I think there's quite a few things we could do there to expand this project even further. Cool. So if you've not joined me on Discord, we have a growing community of people on Discord. So if you head over to kezrobot.com/Discord, you can join the party there. And you can also follow me on social media as well. So I tweet a lot on Twitter at KevsMac, and you can also find me on Instagram where I do a few reels every now and again at Kevin McAleer as well. And if you want to help out the show, there's quite a few different ways you can do that. You can do a super thanks, which I think is on the YouTube. You can on YouTube at the bottom of the screen next to like the next to the subscribe and like buttons, there is a little super thanks button. You can press that. Or if you're watching live now or you want to do a super thanks, so a super chat, you can do that as well. I'm just looking to make sure I've got all my Scream elements and everything loaded, which I have. And that will pop up on screen as well if you do a super chat right now. You can also head over to kevsrobots.com/coffee if you want to buy me a coffee. If you want to download the STL files completely for free, or you just like the content and you want to say thank you, that's the easiest way to do that too. And if also you want to, you can join the YouTube membership program too, just by clicking join at the bottom of the screen on YouTube. So I have a growing list of supporters. So here we are. We have Robert Brown, Matt Kay, Matt Heathcote, Stephen Gale, Tech Cree, Shane Havron, and Curtis Darst. And we've also got, is it Chemi? I'm really bad at names, and you've told me this about twice now. But yeah, we've got Chemi, we've got Tom Weiser, we have Donald Williams, and we have Carlos Mora. We have Jeff Ford, Johan Dahlstrom, and John Paul Jolly, and we also have Tom. So thank you to everybody who has helped grow the channel, helped support the channel, and helped me paying for all these expensive robots that I keep building every week. So thank you to everybody for that. Right, let's get back over to me. I love the way it just cuts the sound dead. And that's it. That's all the slides I wanted to cover off today. So I hope you enjoyed me building this little robot, which I've got just over here. There he is. It's a cute little robot. He says HeyBot on them there. I've just got some blue tack holding. He's a bit angry now. I've picked him up. So I'm just going to put him back down there. And he's got these cute little arms that we can move around. It's reasonably quick to 3D print. I had a few problems when I was 3D printing it just because my 3D printer isn't dialed in properly. I've let it slip a bit and there's a bit of a weird effect there. And I think there was some artifacts on the bottom there. But other than that, it worked absolutely fine. And you can see behind me there, we've got quite a few other things going on. We've got Isaka there with her glowing eyes, and I even put on the what is that, the Kraken detector, which I got when I was in Whitby Steampunk Fair weekend earlier in the year. So quite a few things. We've also upgraded the display behind us, so we've got an extra tier now, so we can put some extra robots on display, so we can get them all sort of lined up there behind me. Cool. So this is the point in the video where if you're watching this on replay, I'll be cutting off the live chat and the Q&A at this point. Otherwise, it'll be a really long video. So I'll say thank you for watching, and I shall see you next time.